So hopefully now you're feeling really confident completing the square when the leading coefficient is 1. Now we're going to move on to how to complete the square when the leading coefficient is not 1. So for example here you'll notice that it's 2x squared. So step number 1, if there is a coefficient on the x squared term, you're going to greatest common factor it out of the x squared and the x terms. This guy is just always something that stays on the end. You never do anything with it except collect like terms in the end. So you're only going to pull the 2 out of the x squared and the 12x. So you're going to be left with 2 times x squared plus 6x, and then this minus 2 is outside of the bracket. And then the process is the same. You have to find that magic number. So you take half the middle term and you square it, and then you add it and you subtract it. So here we've got x squared plus 6x. To make this a perfect square, we have to add 9. Now you can't just add 9, you also have to subtract 9. And notice how they've both gone in the bracket, because this is happening to the 6x. So it's in the bracket with the 6x. But to make a perfect square trinomial, we only want x squared plus 6x plus 9. We don't want this minus 9. So to get rid of it, we take it out of the bracket. To do that, you have to pay the toll. You have to multiply it by the 2 to take it out of the bracket. So you can put plus 2 times negative 9. So some people, right when they create it here, they know that they're going to have to multiply by 2 and they just go straight to writing it like this. I prefer this step and then taking that negative 9 out of the bracket. Now I'm left with this beautiful perfect square. So I'm going to factor it down to x plus 3 all squared, half that middle term. And then I've got 2 times x plus 3 all squared, and then I'm going to collect like terms. 2 times negative 9 is negative 18, minus 2 is negative 20. This would show me that I have a vertex of negative 3, negative 20. I'm going to be opening up, and I'm going to be narrower because I'm going to be stretched by 2. All right, let's try 2. So we're going to find the vertex of these, and then we're actually going to practice graphing them again. So let me just see if I can shrink my page so that I can fit my grid. There we go. Okay. So first off, we want to create this perfect square. So we're going to greatest common factor out that 2. So we're going to greatest common factor out the 2 from only these 2 terms. So you're going to be left with x squared minus 2x. And again, you're only factoring out these 2 terms because this is going to make my perfect square trinomial. And then here we go, we're left with x squared minus 2x. So our whole goal was to get a leading coefficient on the x squared term of a 1 to make it easy. To find the magic number, you take half the new middle term and you square it. So half of negative 2 is negative 1, squared is 1. So I'm going to add 1, but that would change my expression, so I'm also going to subtract 1. Now my perfect square would be x squared minus 2x plus 1, so I don't want this minus 1. To get rid of it, I'm going to take it out of the bracket by multiplying it by the 2 so that it can come out. I'd be left with 2 times x squared minus 2x plus 1 plus 2 times that negative 1 plus 1. Now I'm going to factor, so this is going to factor to x minus 1 all squared, so half that middle term. And then I've got negative 2 plus 1 is negative 1. To graph this, I have a vertex at 1, negative 1. It's going to open up, and it's going to be narrower because I'm stretching it by 2. So I'm going to put my vertex at 1, negative 1. And then, instead of going over 1 and up 1, I'm going to go over 1 and up 2. Instead of going over 2 and up 4, I'm going to go over 2 and up 8 to 7. And then I could try to go over 3 and up 9 times 2 is 18, but it's not going to fit on the grid. So then I can copy these points over to create that symmetry. And then there's my beautiful parabola. There we go. So if you feel confident, pause the video, give this one a go. If you're not feeling confident, try another one with me, and then there's some practice in your homework that you can do. So for this one, I'm going to greatest common factor out that negative 3 from the first 2 terms only. So I'm left with that positive 1x squared. Then negative 12 divided by negative 3 is positive 4x, and then that's going to become my perfect square. To create that perfect square, you take half of your x term and you square it. Half of 4 is 2, 2 squared is 4, so I'm going to add 4, but that would change the value of my expression, so I'm also going to subtract 4. Now the only part of it that I want is the perfect square trinomial, so I have to get rid of that -4. To do that, I'm going to take it out of the bracket by multiplying it by the -3. So here we go. We're left with -3 times x squared plus 4x plus 4. Then I'm going to have that -3 times the -4 out of the bracket, and then that -3 trailing on the end. I've got -3 times. This is going to factor to x plus 2 all squared, so half that middle term. And then this is positive 12 minus 3 is positive 9. That leaves me a vertex at -2, 9. It's going to open down, and it's going to be narrower. So I'm going to go to -2, 9 to get my first point, and then I'm going to open down and I'm going to stretch by 3. So I'm going to go over 1, and instead of going down 1, I'm going to go down 1, 2, 3. I'm going to mirror that on the other side. Instead of going over 2 and down 4, I'm going to go down 3 times that to 12. So I'm at 9, 10, 11, 12. Now if I could, I'd go over 3 and down 9 times 3 would be down 27, which isn't going to fit. So I'm just going to mirror this point on the other side and then connect my dots. And on the other side. Oh, I missed that one. There you go. And so now you can graph a parabola that is written in standard form by changing it into vertex form using completing the square. The next video is going to teach you how to find the vertex in a different way, especially when they aren't easy to complete the square.